We've got bond energy calculation here. 3 stages to bond energy calculations. First stage, calculate bond breaking. Whenever a chemical reaction happens, we have to break bonds first. After that, we need to calculate the bond making. And then the third stage, because after we've broken all the bonds, we need to make new bonds. And the third stage is going to be break minus make. So whatever the total is of the breaking, we subtract the making total, and then that's our final answer. Okay, so 3 very distinct stages. So first off, breaking. Now it's quite easy, well I say quite easy, comparatively easy, because we've got diagrams of the structures of these molecules here. So the first thing we have to do is we have to work out what bonds need to be broken. So to start with, we've got 1 carbon-carbon bond there. So we've got 1 times carbon-carbon. So that's going to be a carbon-carbon. We look at the bond energy needed to break one of those bonds, it's 348 equals 348. Next, I've got 1, 2, 3, 4, 5 carbon-hydrogen. 5 carbon-hydrogen. Carbon-hydrogen is 413, I think. So there's the carbon-hydrogen, that's 413, yeah. So 5 times 413, so that's going to be 5 times 413. What's that? 2065, I think. We'll check that. So let's get that calculator to check that. So 5 times 413, 5 times 413, 2065 equals 2065. Next we've got a carbon-oxygen bond there, just the one of them. So 1 times carbon-oxygen, carbon-oxygen there, 358. So that's 358. And lastly here we've got an oxygen-hydrogen bond. So we've got one of those, 1 times oxygen-hydrogen, oxygen-hydrogen 464, 464. I say lastly, that was the end of the ethanol, but we've got oxygen-oxygen bond here as well, and there's 3 O2 molecules. So we've got 3 oxygen-oxygen double bonds, so 3 times oxygen-oxygen double bond. Oxygen-oxygen bond is 498, and we've got 3 of them, so 3 times 498. That looks like 1494, but we'll stick that in a calculator just to check that as well. So 3 times 498, 1494. Right, now we need to add all these up. So now we've got all our bond energies there, we need to add all of those up. So 1494 plus 464 plus 358 plus 2065 plus 348 equals 4729. So 4729. So that is our bond breaking. That's the activation energy for that reaction. The energy it requires to break all these bonds. Now all these bonds are broken, we can join up and make new bonds. But that's our bond breaking. So that's, I'm going to write that over here straight away in stage 3, 4729. So now we've calculated bond breaking, we need to calculate the bond making. So we've got a carbon dioxide molecule here. This carbon dioxide molecule has got 1 carbon double bond oxygen, 2 carbon double bond oxygens. We've got 2 molecules, so if I draw this second one there, we can hopefully see that in total there's going to be 4. So 1 carbon double bond oxygen, 2, 3, 4. So we've got 4 times carbon double bond oxygen. 1 carbon double bond oxygen is 805. So we need 4 of those. 4 times 805, that looks like 3,220. And then we've got 3 waters. So there's 1 water, let's do another one, and then let's do a third one as well. It's just easier to count them this way, isn't it? So I've got 1 oxygen-hydrogen bond there, 2, 3, 4, 5, 6. So 6 times oxygen-hydrogen bonds, 464. So it's 6, isn't it? 6 times 464. So I'll put that in a calculator. 6 times 464 equals 2784. What we will do as well is check that 4 times 805. Yeah, 32220. Right, so let's add those two together now, and that'll give us the bond making plus 2784 equals 6004. So that's bond making energy. So we're now going to do break minus make. So we said it's 4729 minus 6004 equals minus 1275. Unit is kilojoules per mole. Now that's minus, that minus there means it is exothermic. If the net energy transfer is negative, energy is given out. So this is giving out heat energy. So that's if it's negative, it's exothermic. If it's positive, it's endothermic, it'll be taking energy. But this one, as I say, exothermic. All these questions on elsham-high chemistry.com.